All right, we're going to start chapter 7. We're going to talk about functions in this chapter. We're going to talk about what a function is. We're going to talk about graphs of functions, some function notation, domain and range, all different types of things that have to do with functions. So let's start by first talking about what a function is. A function is a kind of correspondence between two sets where the first set, which we call the domain, corresponds to exactly one member of the second set, which we call the range. Really, an easy way to think about that is that every x has only one y value. You put in an x and you only get one answer out, okay? So for every domain, there corresponds only one range. For every one input, only one output. For example, to each person in the class, there probably corresponds just one date of birth, right? You were born on one day of the year. Or for each barcode in the store, when you go to the checkout and you scan it, it corresponds to one particular item with an exact price, right? And so those are a couple examples of functions. So what if I give you these two examples? Determine whether each correspondence is a function. Remember, every domain has only one range. Every one input only has one output in order for it to be a function. So on the first example, the 4 goes to the 2, the 1 goes to the 2, and the -3 goes to the 5. 4 only goes to one thing, 1 only goes to one thing, and -3 only goes to one thing, only has one output. That is a function. I know that 4 goes to 2 and 1 also goes to 2, but it's still a function because every domain only goes to one range. Look at B though. If I had Ford, Chrysler, and GM, and Ford goes to Mustang, Chrysler goes to the 200, but GM goes to Sonic and the Volt. Obviously there's other cars besides these 4, but in this particular example, do you notice how GM has two different ranges? And so this example would be an example of something that was not a function because GM has two outputs, and so we would say that was not a function. What about these two? On C, I've given you 3 different groups, so let's see if each of these 3 is a function. This time, they wrote it as ordered pairs, points, right? And so hopefully we know that the first number is our x, the second number is our y. So 1 goes to 2, 3 goes to 4, 5 goes to 6, 7 goes to 8. It looks like every x only goes to one y, so it looks like that is an example of a function. What about the second one? It looks like 1 goes to 2, 3 goes to 4, 5 goes to 6, and 1 goes to 7. Ooh, did you hear it? Did you hear that 1 went to 2 and 7? And because that x repeated, that would be not a function. What about the last one? 1 goes to 2, 3 goes to 4, 5 goes to 6, 7 goes to 4. Now, the y's repeated, but every x was different, right? So if every x only goes to one y, then that is an example of a function. So that one is a function. All right, what about D? What if I gave you a picture of a graph and asked you if it was a function? Remember, functions mean that for every x, there's only one y. But look at x equals 2. When I go over to 2, can I go up or down? I have 2 possible y values for that one x value. And so this would be an example of a non-function because every x is supposed to only have one y in order for it to be a function. So you should be able to tell if something is a function, whether I give you a list of domain and ranges, maybe some ordered pairs, or even a graph. Can you determine whether it's a function or not? All right, let's look at example number 2 in this video also. It asks us to determine whether each correspondence is a function. And so this time they give us kind of a word problem. It says in A, the correspondence that assigns a person his or her weight. Well, if I ask you what your weight is, don't you just have one weight? Okay, well, it might vary a little bit from day to day depending on what you were eating the night before. But that is a function because if I ask you what your weight is, you would really just give me one answer for that particular moment. So in that instance, it would be a function. What about B? The correspondence that assigns the numbers -2, 0, 1, and 2, each number's square. All right, so I have the numbers -2, 0, 1, and 2, and then I have their squares. So what's -2 squared and 0 squared and 1 squared and 2 squared? Well, -2 squared is 4, 0 squared is 0, 1 squared is 1, and 2 squared is 4. You see how I just wrote it once? All right, so if I go -2 to 4, 0 to 0, 1 to 1, and 2 to 4, does every x only go to 1y? Yeah, that would be an example of a function. So maybe writing it out and kind of drawing arrows so you can see that every x only goes to one y value. Every domain only goes to one range. Maybe that's easier to kind of figure out if it's a function or not. All right, last one in this video, the correspondence that assigns to a best-selling author the titles of books written by that author. So my domain is the author. The range is all the books that author writes, right? Now, because one author can write lots of different books, this would be an example of something that was not a function, because an author can write lots of different outputs, different books, right? All right, make sure you can determine if something is a function or a non-function, given lots of different ways to write the problem.